Yeah, so good evening. So in the last class, we see in properties of algorithm. So in the last class, we see in, right, I think 25, 12, 25. Sorry, 29, 12, 25. Yesterday, yes, this is the yesterday's class. 25, 9, right, 20. I'm repeating once again. This is the yesterday's class, 29, 12, 25. Definition I said, properties, right? Example I given, properties I said. Now let's move to today's date. I think today's date is, let me write here. I'm writing, so 30, 12, 25. Right, this is the today's date. So I'm starting, right? If audio, video, any issue is there, let me know. I hope everything is fine. Now let me write. So properties are completed. Next one, steps needed. Steps needed to design algorithm. Steps needed to design algorithm. Steps needed to design algorithm. Right, so I'm writing the first step. If you want to design algorithm for any problem, first step, knowing problem clearly. That is called problem definition. The first step is going to be problem definition. If you want to design algorithm for any problem, the first step is going to be problem definition. Knowing problem clearly means for every input, what is the output we have to know. If A input, output is B. C input, output is D. E input, output is F, and so on. Y input, output is Z, something like that. Knowing problem clearly for every possible input, what is the possible output. That is called problem definition. Second step is going to be, right? Second step is going to be, but however, remember, book to book, it will differ. So organization to organization, right? Steps will be differ. In bigger organization, so many steps are there. In smaller organization, less steps are there. Right, I cannot say, right, in every company same number of steps are there. In every book also same number of steps are there. We cannot say that. So when you say bigger company, so they will take more money from the client, so definitely they can go to the more detail, more clearly, more depth they will do. So suppose assume that you want to have one, you want to start your own business, you need one website or one application, mobile application you want to have one website or mobile application you want to your business, right? What is the cost to build it? It depending upon which company you are going. Suppose if you go to startup company, maybe they will finish it off within 50,000, but most of the things may not work. If you go to some other bigger company, right, I think 50,000, right, mostly 99% many things will fail. If you go to some little bigger company, they may take, right, they may take approximately 50 lakh, right? I think 50-50 will work out, right? 50 lakh means 50-50 it will work out. If you go to the little more bigger company, maybe I think they will take 5 crore. If you go to some more bigger company, they may take 50 crore. So little more bigger company, they may take 500 crores, it depending upon that. So depending upon the company, the details will be keep on changing. So that is the reason whatever steps I am saying, I cannot give guarantee. In every book, same steps are there. In every organization, same steps are there. We cannot give guarantee. So to design the algorithm for any problem, first step is problem definition, right? So different names are there. Names also different. Organization to organization, names will be differ. Number of steps also will differ, right? So cost also will differ. Many things will come into the picture. I will give a rough idea. Steps needed to design algorithm. First one, know the problem clearly, problem definition. Second one is design algorithm. Design algorithm. Second one is design algorithm. So algorithm subject having so many designing technique, right? So which designing technique is more suitable, you have to design. So let me write now. So one of the designing technique is divide and conquer. one more designing technique is greedy technique. One more is going to be dynamic programming. One more is going to be backtracking. One more is going to be branch and bound. There may be so many techniques, right? Design algorithm, I think it is something like nowadays you will see on the internet, right? Pattern matching, right? So if any problem, if anyone asks you, instead of trying always some random way, right, there are so many patterns are there. The given problem belongs to which pattern? So I can write one more model also, right? Nowadays algorithm is slightly changed. So normally people will think that one designing technique is the DSA, another one is greedy technique, another one is a dynamic programming, another one is backtracking, another one is branch and bound. But nowadays a few more patterns, right? Some those people who are working in the right big companies like Google, Microsoft, right, bigger company Amazon, so they find out some more patterns, right? So same only, but little more details they done. Little more details. I think as of now we are studying only 5. Nowadays, right, new generation, right, new people, the people who are having a lot of experience in the domain, because nowadays DSA is the one which is deciding the all the things, right, which is deciding the right what the capability of any person, what the capability of a particular company. DSA is the one which is deciding. So many patterns are there. In the divide and conquer itself there are some pattern. In the greedy technique itself some more pattern. They divided little more further. Some patterns like sliding window, some patterns like two pointer, some, right, some more pattern like right, I think prefixes, some, there are so many variations are there. But general terms, right, these are the things: DAC, greedy technique, dynamic programming, backtracking, branch and bound. Right, when you are solving the practice problem, you will see all the pattern indirectly, directly, all came from, right, these things only. Indirectly, directly, all came from these 3 things only, sorry, these 5 things only. So again I'm starting now. If you want to design algorithm for any problem, first step is know problem clearly. That's the first step. Second step is design the algorithm, means in the existing algorithm to your problem which is more suitable, check. Some people, I asked one of the, right, in one of the interview I asked one of the student, right, so how will you solve this problem? So that person is so intelligent, that person seen the problem, that person saying that, yeah, this problem I can solve using merge sort or using merge algorithm. Oh, I said, okay, fine. This problem I can solve using merge algorithm, which internally contains something like maybe divide and conquer. Some right. I asked one more person, how will you solve this problem? He said that, yeah, I can solve this problem using I think 2 pointer, something like that. They said this is the meaning of designing algorithm. You no need to design algorithm every time from scratch. Some people are thinking that I will design algorithm every time from scratch. You can do it. Designing algorithm every time from scratch, you can do this, but time consuming. The best idea is so many algorithms are already designed. Your problem is approximately like what problem which is already existing, right? This problem is something like this. Oh, by doing some small changes we'll get the answer. One is writing from the scratch, another one is existing things, existing pattern, you can use it. So that is the meaning of designing algorithm, right? So in the existing algorithm or existing designing technique, which designing technique is more suitable to your problem, you decide. That is called designing algorithm. Suppose second step is over, means almost you got the answer, right? So I think you got the algorithm. Almost you got the algorithm means normal English lines. Now what you do is, right, using that algorithm, draw flowchart. Because you are already having algorithm, draw flowchart. Right, fourth one is going to be after flowchart is available. After flowchart is available, just to do testing. Right, flowchart is available just to do testing by applying all possible test cases. Right, when second step is over, means algorithm you got. Third step is, to that algorithm you are drawing the flow chart. You are drawing almost like a machine, right? So to that machine, by giving different inputs, please verify output is coming or not. Test cases applying. Okay, everything is fine. Test cases also working fine. If not working, right, go to the right designing algorithm. Right, designer, you say, whatever designing technique you are using, right? I done the flow chart, I done the testing, everything is fine. Few small things are missing, they will do some change. Testing also they will be done again. So it will keep on continue. Let us assume that everything all right. Let's go to fifth step. Everything all right. Now you can go to, right? Lastly, you can go to, right? I think testing is done. Right? Now you can go to, yeah, I think analysis you can do. Right? Sixth one, you can do. Lastly, coding you can do. So remember, company to company, right? Organization to organization. The small company, big company, steps will increase, steps will decrease. In startup company, these all steps are one step only. In the bigger companies, these all steps are maybe 6 steps I written. Maybe in the bigger companies, those may be 100 steps. In the smaller company, these 6 steps are one step only. Right? In some companies, the same steps, little bit changes. Right? I think fifth I done the analysis, next one I done the coding. Anything is okay, right? I think absolutely there is no problem. Do analysis, then afterwards go to coding. Coding means lastly, this is also called as implementation. Coding means implementation. Right? I hope everyone is fine now. Analysis followed by coding, which is also called as implementation. Right? Problem definition, designing algorithm, flow chart, testing, analysis, coding. Right? So what you may say that, sir, what is the analysis? So remember, 4 steps are completed means everything is perfect. But the thing is, analysis you have to do before going to do coding. Do analysis. Analysis purpose is you have to identify, first of all, the algorithm whatever you have, what is the time complexity, what is the space complexity. Suppose these two things are, it is taking more, then I think this algorithm is not a good idea. So you have to find some other algorithm. Suppose these two things are right, this algorithm taking these two things less, so I think it's a very good algorithm. So you can go for the coding. Coding means implementation. So remember, bad one no need to implement, good one you have to implement. First, how you decide good one or not? Based on the analysis we will decide. What analysis will do? Finding time complexity, space complexity. Using analysis you can find out time complexity, space complexity. Suppose time and space is less, means algorithm is good, then you can go for the coding, which is called implementation. Means some programmers will come, the algorithm whichever we have, which is there in the form of English language, they will do in some language, they will do coding. Right? Remember, after coding also again testing is there. That is a right language dependent testing. So but the analysis what we are doing, the fourth one is a testing. The testing what we are doing is logic we are testing. After coding also over, you may do testing, that is going to be coding test. Right? Coding, right? Whatever coding you done, testing for that. But after flow chart is over, if you do testing, logic you are testing. So there are so many. That's what I'm saying. Bigger company having many steps, smaller company having smaller steps. So some people are asking, sir, when will you do coding? When I confirm the algorithm which I developed is everything is perfect. Time complexity, space complexity less. Means after analysis, everything I find out perfect, then I will go to coding. Suppose while doing analysis, I got to know it is taking more time, it is taking more space, then I may not advise, I may not ask them go for coding, because already I know that it is a waste algorithm. Then what is the requirement of going to coding? Right? So be careful. So these are the steps. No one will ask you, but it is better to know. Right? One way. So right, remember, first of all, what is algorithm definition? This one. Example, this one. Next one, properties of algorithm. These are the things. Next one, what are the steps to design algorithm? Know the problem clearly. Afterwards, from the existing pattern, which pattern more suitable to your problem? Please get it. That is called algorithm design. After getting the algorithm, draw flow chart, do testing. Means the flow chart, whatever you drawn, everything okay or not, do the testing. Everything perfect, then go for analysis. What is the time, what is the space, you decide. Suppose time and space also best, then lastly go for coding. After coding, then if you want, you can write the once again testing. This testing is on coding. Previous testing is on logic. Okay, fine. Perfect now. So you know very well algorithm subject goal is designing a algorithm. That is the purpose of algorithm subject. Next one is going to be analyzing algorithm. Right, that is the reason people used to call it as algorithm subject name is DAA, design and analysis of algorithm. Right, analysis of algorithm analysis and design. This is also one more name. ADA, algorithm design and analysis, different names. Yeah, these are the two main things which we are going to concentrate. Now let's write the analysis. Let's write the analysis. Concentrate everyone. Let's write the analysis. First chapter, analysis. First step is please write analysis. In my opinion, today's class is just started now. In my opinion, today's class is just started now. Remember, in my opinion, today's class is just started now. Take care, right? I'm starting, everything ready. Everything ready, I'm starting. Please be careful, I'm starting now. Analysis. Purpose is, right? Analysis purpose is finding time complexity, space complexity. Purpose is finding time complexity and space complexity. What is the purpose of analysis? Finding time complexity, space complexity. Right? Analysis purpose is finding time complexity and space complexity. Okay, that is the purpose of analysis, finding time and space complexity. Now next one, analysis will be two types. What is the purpose? Analysis purpose. Analysis purpose. Finding a time complexity and space complexity. That is the purpose. Right? So what is the purpose of analysis? Finding time complexity, space complexity. Next one, analysis, how many types? Two types. So one is going to be post-theory analysis. Another one is priori analysis. One is a post-theory analysis, another one is a priori analysis. Post-theory analysis and priori analysis. There are two analyses there, post-theory analysis and priori analysis. Right? So I think if you see the post-theory analysis, so this analysis is based on, right? Remember, this analysis is based on type of processor. Next one, type of compiler or language of compiler. But here, in the case of the priori analysis, no real things are not involved. Right? So, post-theory analysis is based on type of processor and language of compiler, but it is independent of. It is independent of type of processor and language of compiler. It is independent. Right? Post-theory analysis is dependent. Priori analysis is independent. So real, you know very well, time complexity is based on the processor speed. Right? But when you want to find time complexity, you should know compile time plus running time. Compiler also involved. What type of compiler you are using? So if anyone asks what is the time complexity, so time complexity means running the program, how much time it will take. While running program, how much time it will take. While running means CPU will come to the picture. So how much CPU time it will take. How much CPU time is based on type of CPU. Next one, you have to compile also. Compilation time is based on what type of compiler you are using. If you are using compiler, right? Compiler means software. So, right, compiler is a software. To write the compiler means to write the software, if you use a slow language, compile time is more. To write the compiler, if you use the faster language, compile time is less. So, time complexity based on the language of the compiler, type of processor. If you depend on these two, that is called as posterior analysis. If you don't depend these two, that is called priori analysis. Second one, because of real things you are taking into consideration, you will get exact answer. You will get exact, right, approximate answer. Third one, but the problem is system to system different answer. Different answer from system to system. Real thing you are not taking into consideration, na? Different, right? Different answer from system to system. Different answer from system to system. Because you are taking real things into consideration. But here, same answer in every system. Because it is independent, na? Same answer in every system. So please take care about these three steps. Analysis, what is the analysis purpose? What is the purpose of analysis? Time complexity and space complexity finding. Next one, analysis is how many types? Posterior analysis, priori analysis. What is the posterior analysis? It is a dependent on type of processor and language of compiler. In the priori analysis, it is independent. Because of it is a dependent, right? Real things are changing, time also changes, right? It will give exact answer. But second one, because of anyhow it is independent, approximate answer. So third step, different answer from system to system. Real things are changing, answers also changing. But real things are changing, answer will not change. The reason is, right, we are independent. So same answer in every system. Try to understand. Same answer in every system, right? So analysis purpose is finding time complexity, space complexity. Analysis will be two types: posterior analysis and priori analysis. Posterior analysis contain 3 steps. Priori analysis also contain 3 steps, almost like opposite. Be careful from now onwards. Write down. Write down the first one. Total industry follows priori analysis. Priori analysis. So be careful, priori analysis. Different answer from system to system, same answer in every system, right? So be careful, priori analysis. Remember, it is independent analysis. Total software industry follows priori analysis only. So, right, this is also called as, right, this one. So posterior analysis and priori analysis, right? Priori analysis is independent analysis. Posterior analysis is going to be dependent analysis. Dependent analysis, priori analysis, independent analysis. Now come here. From now onwards, be careful. Priori analysis means it is independent how? It is independent how, right? Let's check. What exactly this method I'm writing? It is a determination of, it is a determination of order of magnitude of a statement. It is a determination of order of magnitude of a statement. It is a determination of order of magnitude of a statement. Remember, it is a determination of order of magnitude of a statement. What exactly it is, you will see one by one. Be careful from now onwards. Be careful. Right? How to find out time complexity, that is a goal. Right? So analysis purpose is finding time complexity, space complexity. Right? So analysis will be two types. Right? What is the priori analysis? Yeah, I think everyone know. Posterior analysis is depending upon actual things. Priori analysis is, it is an independent analysis. What means, what exactly it is? It is a determination of order of magnitude of a statement. What exactly we will get to know now. Everything perfect. Now see this one, time complexity problems. Problems on time complexity finding. Time complexity finding. Please be careful, everyone. Time complexity finding. Everyone, be careful. Time complexity finding how? So see the first problem. Example 1. Just wait. Yeah, example 1, first problem. Time complexity finding, example 1. Make sure everyone listen. Make sure. First problem, mean. First problem, mean x equal to y plus z. Right, main x is equal to y plus z. It's the first problem. Example 1. Be careful from now onwards. Example 1, main x is equal to y plus z. To this problem, I want to find out time complexity. Remember, we are using priori analysis. We are using priori analysis. Right? Careful. So, what is the meaning of the priori analysis? It is a order of it is a determination of order of magnitude of a statement. Means, what is the meaning? Whenever this, right? See this one. First of all, identify how many statements are there in this program. How many statements are there in this program? First of all, determine. If you observe, one statement is there. Right, this program contain one statement. Okay, that's okay. Whenever this program is running by CPU, whenever this program is running by CPU, right, how many times this statement will run? This program having one statement. Okay, whenever this program is running by CPU, how many times this statement will execute? One time. So that is called order of magnitude of that statement. Order of magnitude of that statement, that is one. So order of magnitude you got, while running the statement will execute one time. So order of magnitude of the statement is 1. So finally time complexity is big O of 1. So time complexity is going to be big O of 1. Finally, time complexity is big O of 1. Careful. So you may say that's a big O of 1. Why not omega? You can write omega of 1 also. You can write theta of 1 also. You can write anything. So time complexity of the given program is big O of 1, you can write, or omega of 1 also you can write, or theta of 1 also you can write. That is the first problem. What is the time complexity of this problem? Right, big O of 1, omega of 1, theta of 1. That is example 1. Let's go to example 2. I hope you got example 1 clear. Let's go to example 2. Remember, I'm going to teach from now onwards 30 problems. I'm going to teach from now onwards 30 problems. So please be careful. Problem 1, I done. Only one statement. That statement while running will execute one time. Right? So 1. So you can write whatever order of magnitude is there 1. You can write big O of 1, omega of 1, theta of 1. So first problem, time complexity, big O of 1, omega of 1, theta of 1. Whatever you want, you can write. Okay, fine. Let's go to example 2. Until now, any doubt, let me know. Until now, do you have any doubt? So if no one is watching, then whom you are teaching? Yeah, I hope someone will teach, someone will watch. Right, after some point of time, some people will come and they will watch. That is the meaning of life. Thanks for asking. Very good question. Right, let's move to the next problem. So example 2, if you see the example 2. May next one is x is equal to y plus z. Next one, for I is equal to 1, I less than or equal to n, I plus plus. Next one, x is equal to y plus z. End of this. So this program contain, if you observe clearly, two statements. This problem contain clearly two statements. The first statement, it is the second statement. This program contain two statements. 1, 2. First statement and the second statement. So first statement, order of magnitude, if you see, 1. Second statement, order of magnitude, if you see, n, y, right? I is equal to 1, the statement will execute. I is equal to 2 also, the statement will execute. 1 execute, I is equal to 1 execute, 2 execute, 3 execute, and so on. I is equal to n also execute. Right? Whenever I becomes n plus 1, condition is failed, you will come out. So first statement order of magnitude is 1. Second statement order of magnitude is n. So overall program order of magnitude is n plus 1. Overall program time right, order of magnitude is n plus 1. Now overall program order of magnitude is n plus 1 can be written, right? So forget about constant, big O of n, omega of n, theta of n. So these all are correct. This is the second problem. This is the second problem. Right? This, and until now I covered two problems. So please careful everyone. This, right, second problem contain two statements. First statement order of magnitude is 1. Second statement order of magnitude is n. Overall become n plus 1. So actual answer is n plus 1. But remember, n plus 1 can be written as, just forget about the constant, big O of n, omega of n, theta of n, all correct. So second problem, time complexity, right? So n is the answer. You can keep any symbol. I hope you are okay with the second problem. Let me know anyone having any objection. Right, someone is saying that, sir, hello sir, I have completed my BTech degree in 5 years due to some year back course. So will I be eligible for ISRO, BARC, DRDO scientist? So government jobs, na? Akshata. Yeah, Akshata. I think so. Akshat. Yeah, Akshat is saying, asking like that. So you just see Akshat, what is your age? You check. If you follow that age, their age criteria, you are eligible. Just see the only age. Just see the, just see the, right? Just see the, hello? Just see the age criteria. If age is okay, really no problem. If age is okay, really no problem. They want just government, na? Just they want rules you have to follow. Are you following rules or not? Verify. That is more than enough. Okay, I think two problems I done. You are eligible. In my opinion, you are eligible. I think approximately 20, right? I can say 28 or 30. 28 or 30. I think you are eligible. So please, anyhow, you can check one time. You can check one time. If you have any doubt, you can WhatsApp us. We are going to help you. Just WhatsApp me. Still, if you have doubt, just go to the ISRO or BARC and verify one time. Verify one time. All right. Are you following the age criteria or not? If you are following, you are good to go. If you are following, you are good to go. So second problem also I done. First problem, time complexity. Right? So I think order of magnitude is 1. Time complexity is big O of 1, omega of 1, theta of 1. Second one, if you observe two statements, first statement order of magnitude is 1. Second statement order of magnitude is n. So n plus 1, n plus 1. So actual answer is n plus 1, can be written as big O of n, omega of n, theta of n. Okay. Okay, second also completed. Let's go to third problem. Everyone, please concentrate third problem. Hope you don't have any doubt. If you have doubt, you can ask me. See, I came here to teach. If you ask doubt, I will help you. If you don't ask doubt, I will keep, right? I will normal, keep quiet. I will do my work and I will go. So those people who are watching, any small doubt also there, you can ask me. See, Akshat having some doubt, he asked. I helped. Right? If you have doubt, you can ask. Right? I know that, right? If you ask something, most probably whatever you are asking, I know. right? So I will help you. If not, I will keep on teach. As a teacher, my goal is, my responsibility is only teaching. I just teach. If you listen, well and good. If you ask doubts, I will clarify. Otherwise, I will keep on teach further problems also. Let's see the example 3. Main. See the third problem. So first statement, x is equal to y plus z. Second statement. See the second statement. First statement is x is equal to y plus z. See the second statement. For I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. It is the second statement. Remember, for is not a second statement. Inside for what is there? That is the second statement. Let's go to third statement. For I is equal to 1, I less than or equal to n, I plus plus, for j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. It is the, I think it is a third statement. Remember, for loops are not third statement, but inside for loop, whatever is this one is a third statement. So this problem contains 3 statements. Observe carefully. This problem contains 3 statements. So I given the numbers also. Third problem I am explaining, which internally contain 3 statements. Loop, don't worry. Don't think much about the loop. You please don't think about the loop. Right? So first statement, no loop is there. No loop means order of magnitude is 1. Second statement is part of the loop. This loop will repeat n times. So I value 1 will execute, I value 2 will execute, I value 3 will execute, I value n also will execute, I value n plus 1, it will fail. So this will execute n time. Right? If you see the third statement, if you see, for each I value, j will execute n time. For each I value 1, this will execute n time. I value 2, this will execute n time, because each I value j also running. I value 1, j will execute 1, 2, 3 and so on n. I value 2, j will execute 1, 2, 3 and so on n. So every time n times it is repeating. Every time n, n times n, which is going to be n square. You may say that, sir, how, sir? You may say, how, sir? Each I value, see, I value 1, n time, j loop. I value 2, j loop n time. I value 3, j loop n time. I value n, j loop n time. N times n, n square. So total program order of magnitude, if you observe, n square plus n plus 1. This is the total program order of magnitude. 3 statements are there. Every statement order of magnitude I written. Total program order of magnitude is n square plus n plus 1. Right? Now see, total program order of magnitude is n square plus n plus 1. This can be written as big O of n square. Can also be written as omega of n square. Can also be written as theta of n square. Right? This is the third problem, time complexity. Remember, I am going to cover 30 problems. So 3 problems I done. So if anyone asks you from today onwards, find time complexity. First of all, identify how many statements. Second step, every statement order of magnitude you find out. Just add all of them. Whichever bigger, that is the answer. Bigger is n square, so big O of n square, omega of n square, theta of n square. Do you have any doubt till now? 3 problems I done. Do you have any doubt? Check. Yes. Thank you, Aman. Thank you so much for all your comments. Let me know if you have any doubt. Anyone having any doubt, let me know. Little doubt also there, let me know. So 3 problems I done till now. Right. Perfect, Aman, don't do until blocking. So yeah, I'm blocking him. Chalo. Yeah, next. Anyone having any doubt, let me know. So three problems I done. Three problems I done. Let's go to fourth problem. Three problems I done. Let's go to fourth problem. Example 4. Main. So fourth problem I am writing main. Example 4. Main. Next one. Yeah, let me write one more thing. So three problems I done. Fourth problem. Okay. X is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus, okay. X is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus for j is equal to 1, j less than or equal to n, j plus plus x is equal to y plus z. So end of this. Okay. So third problem, whatever I said, I think this is also almost similar. Third problem, whatever I said, this is almost similar, right? No difference at all, right? But to see the difference, small difference I want to do. That is the reason I given this problem. Please see this. This may be n by 10. This is n by 2. Assume this is n by 3, right? Let's check one by one what will happen. First statement order of magnitude is how much? Second statement order of magnitude is how much? Third statement order of magnitude is how much? Right? First statement order of magnitude is how much? Second, third. First statement order of magnitude, if you see, 1. Second statement order of magnitude, if you see, 1, 2, 3, and so on, n by 10, right? Which will goes to n by 10. Third statement order of magnitude, if you see, right? I think each I value 1, 2, and so on, n by 2. J value every time n by 3, right? So let's see this one. First time n by 3. Second time j value n by 3. Third time j value n by 3, and so on, right? Lastly, n by 2 time j value n by 3. So like that. So finally n by 2 time n by 3, which will goes to n by 6, right? I think everyone is fine. Now let's find out order of magnitude of total program. Order of magnitude of total program. I think if you observe 1 plus n by 10 plus n by 6, right? That is the order of magnitude of total program. Now if you observe n by 6 plus n by 10 plus 1. So if you see this one bigger one, n by 6. So this one can be written as 1 by 6 into n, which is nothing but big O of n, omega of n, theta of n. So like this, just very simple. Whoever is the bigger one, take it. I took. So 1 by 6 into n. 1 by 6 constant, na, ignore. So n. So answer is big O of n, omega of n, theta. This is the problem number 4. This is the problem number 4. Until now, I done 4 problems. So nicely I written. Trust me, very clearly I am writing. Very clearly I am writing. So, example 1. Right? Any little doubt also. I am going to teach 30 problem, not 1 or 2. 30 problems I am going to explain. If you really okay, 30 problems means time complexity, you will get the clarity. Time complexity, you are going to get the clarity if you clearly observe what is happening here. Small doubt also there, please ask me, I will help you. Sir, you done the 4 problems. In this problem, I have doubt. You ask me, I will help. You ask me, I will help. Check one time. Everyone try. Yeah, let's move to next problem. 4 problems I know. Let's go to 5th problem. Hope no one having any doubt. 4th problem also I done. So let's go to 5th problem. Let's go to 5th problem. Example 5. Example 5. Right, so this is going to be very interesting problem. Check here. Main, right? Main. So let me write here. Main. So afterwards, I'm writing. I'm writing. X is equal to y plus z. A is equal to b plus c. Z is equal to a plus x. So like that you written. X is equal to y plus z. A is equal to b plus c. Z is equal to a plus x. Right? I think if you observe clearly, just 1 minute. Yeah, so if you observe clearly this program, there are 3 statements in this program. There are 3 statements. If you observe clearly 5th problem, there are 3 statements. First statement, order of magnitude is 1. Second statement, order of magnitude is 1. Third statement, order of magnitude is 1. Right? So if you add all of them, 3. Every constant can be written as, remember, 3 constant, na? Every constant can be written as 1. Big O of 1. Omega of 1, theta of 1, right? Every statement you write 1 1 1 1. So time complexity of this program is, just add all of them, 3. So 3 can be written as big O of 1, omega of 1, theta of 1. So like that you write. Okay, you written all. It's perfect. So from now onwards, everyone remember from now onwards. Right? So 5th problem, please careful everyone. From now onwards, everyone remember. Right? So in any program, if you are finding the time complexity, if loop not there, no loop, time complexity constant. If no loop is there, time complexity constant. If no loop, remember, time complexity means loop only. If no loop, constant. Constant means what? Big O of 1, omega of 1, theta of 1. When someone say what is the time complexity of this program, just verify how many statements. Okay, 3 statements, that is okay. But is there any loop? No loop. If no loop, constant is the answer. If no loop is there, constant is the answer. Understand? If no loop is there, constant is the answer. Right? Some people are asking, sir, loop is there, then what is the answer? Sir, if at all loop is there, remember, if loop is there, right? If loop is there, loop is the answer. I think it is a loop. Then answer is that only. If loop is there, answer is that only. Some people are asking, sir, more than one loop, this is also loop, this is also loop. More than one loop, larger loop is the answer. Right? Larger loop is the answer. If you want, you can check. So time complexity means loops only. No loop, constant. If loop is there, right? Loop is the answer. If more than one loop, bigger loop. Time complexity means bigger loop. Let's go to the 4th example. In the 4th example, if you observe, is there any loop? Yes. So what is the bigger loop? N by 10, N by 6. N by 6 time complexity means loop. Loop means if at all more loops, bigger loop. But because of actually N by 6, so but 1 by 6 is a constant. You can ignore constant. So big O of N, omega of N, theta of N, something like that. Let's go to example 5. In the example 5, if you observe no loop, time complexity constant. If no loop, time complexity constant. I hope everyone got it. Let me know anyone having any objection. Till now, I said 5 problems. Till now, I said 5 problems. Any small doubt also there, let me know. Ready, sir? I have this doubt. You ask me, I will help. Little doubt also. Please check. Sir, I have this doubt. You ask me, I will help. And one more thing is I want to say to all the people, right? I want to say all the people. So please listen. Algorithm. Algorithm will take approximately 20 to 25 days. Program will take approximately 10 days. Next one is the data structure. Data structure. It will take 20 to 25 days. So overall, if you observe 60 days. Upper bound, 90 days. So within 60 to 90 days, right, DSA will be over. DSA will be over. Next one. One more 60 to 90 days. One more 60 to 90 days. Right? So 500 problems we will practice. We will practice. So I want to say, right, finally, within 5 months, you will be perfect with the DSA. You can crack, right, big companies also. Starting from scratch, big companies also you can crack. Just keep 5 months deadline, right? 2 months for the preparation, 2 months for the practice, right? On an average 5 months. If you take the 5 months, you are going to be good in the DSA, right? Just started now. I think this batch is started. Let me see here. This batch is started 29th. It is a DSA batch number 3 started, right? So it started on the 29th. It will over most probably 2 more months. Syllabus will be over, 2 more months. Practice will be over. Upper bound is 5 months. Within 5 months, you will be good in the DSA. 80% offer is going on. Utilize. Small doubt also there. This is our phone number. This is our WhatsApp number. You WhatsApp us. We are going to help you. 80% offer is going on. Please use it. Right? Fine. Yeah. So we'll meet in the tomorrow's class. 5 problems I done today. Right? In the next class, I'm going to do, right, I think one more 25 problems. One more 25 problems we are going to do. Yeah. Thank you. See you in the next class.